Login acceptance.
And now we're rolling. All right, so welcome to, I guess it's one of the last session of the second day of Devoxx Poland. Super excited to be here, super excited. Are you folks excited? Did you get a good couple days? Huh? Couple days, good one, like some good information, some good speakers probably. Yeah? Nice, nice, nice. I used to have this as a for my screen sharing, but like super excited that the projector is finally working. Last minute check if you're in the right room. Here's going to be some live coding of Spring Boot. We're going to talk a little about Kafka, stream processing, and after that we'll try to ship it to Kubernetes, to production, like from the stage. So in 40-something minutes, we're going to be doing a lot of things. So specifically, how many of you Java developers we have here? How many of you using Java 8? Java 6? Thank God. Thank God. So Java 8, as you know, as many of you know, that introduced us to Java streams, right? And with streams, they also introduced some of the functional interfaces that allows you to model different types of data processing things. And today I will show you how some of the things that you already know from Java can be easily transformed to something that will, by some magical thing, will turn into the Kafka producer or Kafka consumer or even Kafka stream, without actually writing like a specifically thing around the Kafka API, except the Kafka streams, because there's a specific API needs to be taken into account. So I'll show you, we'll start with how to produce data into Kafka topic, and probably many of you already, if you here, probably you're interested in Kafka, right? How many of you interested in Kafka here? All right, except Tim. Okay, few people, I see. So I hope you will, for those of people who are not interested and want to learn something, it will spark some interest. But I will start some of the unconventional approach how you can do this with Kafka. So we're starting with Java interfaces, and after that, these Java interfaces will automatically start producing messages. Same automatically, we're going to be doing consumption of the messages from the Kafka, and after that, we'll do some processing of the data and some of the cool things that you also can do with Kafka streams in this case. My name is Viktor Gamov. I work as a developer advocate in a company called Kong. We do all things cloud connectivity stuff. And I speak to developers. I produce different videos, produce different tutorials. Super interesting person. Follow me on Twitter, please, by all means. I also happen to be co-author of the upcoming Manning book, Kafka in Action. And only today, or actually, you can take the picture of the slide and you can buy it whatever you want, if you'd like. Some people know there are ways to find the materials on the internet without buying, but there's no such people in this room. All right, so today, stream processing, Kafka 101, very briefly, and more importantly, I will show you where you can learn this stuff. So we're going to be doing the start.spring.io. This is the place where you start your Spring Boot applications. I will show you different approach, or like a functional style of writing your application using Kafka, using Kafka streams. And we will try to, ship it, because runs on my laptop doesn't count, right? So your boss wants to see results, so when the results supposed to be somewhere in production. And production, in many cases these days, are Kubernetes. Any Kubernetes enthusiasts here? You probably want to stick around after Devoxx, because I do have a meetup where we talk about Kubernetes in more details. So that's start.spring.io. It's a screenshot, but let's jump right into action. So from this, there would be no slides. There would be live coding if something will break, meaning that I suck at live coding. So in this case, start.spring.io, that's the place that we know where we need to start our project. Some people like to start this from the IDE. Some people like to do this from the console. I like to do this from the web. So I'm going to be using Gradle project here. Stable version, because again, demo on the stage needs to be stable, right? Devoxx, we're gonna do a Kafka Spring, and that would be it for our application. We're making jars. Java 11 is our default, right? Which version you running in production? Java 11? Anyone? Okay, so good stuff, because Java 11, it is a LTE, and Java 17. Good thing that you are here, because there's another talk talking about Java 17, probably people who are running Java 17 already there. So let's do some of the dependencies. Spring Framework has a wrapper around Kafka API. So we're going to be using this, not directly, because we're going to be using a thing called Cloud Streams. So Cloud Stream. Next thing, in order to Cloud Stream, to teach Cloud Stream, this is like a functional style to teach to produce data to Kafka, the jars that are responsible for working with Kafka needs to be available in class path. In order to do this, we need to add this dependency. So I'll do Kafka, and I'm also adding Kafka streams. Because I am lazy, I'm adding Lombok, because probably I should start with Kotlin, but Kotlin was today morning, so today we'll do Lombok. And obviously, we want to do some of the reactive web, so the results of our computation would be available through APIs. All right, so in this case, let's check if we do have everything we need. Cloud Streams, Kafka, Kafka Streams, Lombok, reactive web. Check with my, so it looks like I do have things in the right place. So I will have some macros here, because, zip. So I'm unzipping this one from my, going into download, zip, and Kafka Spring 2. I'm not the master of the terminal, so that's why I'm switching to my second brain, which is IntelliJ IDEA. I will be just approving some of the code completion that IntelliJ IDEA will provide. Now, so while it's loading, in order to be like a little bit interesting with the live demo, instead of generating some of the random data or maybe quoting some of the poems that you know by heart, Tim, I will be using some library that will generate this stuff for me. The library called Java Faker. So in my, let me do this a little bit bigger for you. You think it would be better? It would make me a better live coder. I can do that, no problem. That's better? Hopefully this makes my code look better as well. Love it. Okay, so let's do this one. So I will be bringing some of the Gradle dependency of Java Faker. So Java Faker is a library that was developed for Ruby folks some time ago, and Java people found this very interesting. So it has fantastic set of tools that you can use to generate some of the interesting data. It has data that will look normal, like if you need to generate some of the addresses, you need to generate some of the first name, last name. I use this for my Chuck Norris quote. So this is what we're going to be doing. We're going to be sending Chuck Norris facts about Chuck Norris into Kafka, and I'll show you how you consume those quotes from Kafka. And after that, I show you how you can process this and count how many times Chuck Norris can do run house kick. Does it ring a bell? Do you guys know Chuck Norris here? It's like the guy from 90s, like kickboxing stuff, some of the like badass videos, like Delta Force. No? The Texas Ranger. You need to catch up on the popular culture here. I think you will enjoy this. It's kind of interesting. All right. So we're starting with our Spring Boot application. And the way how it works in Spring Boot, you need to define beans. And in order to define my producer that will write data somewhere in the Kafka, I need to define one bean. Remember on the slide that I showed you with this interesting comparison between the Kafka aspects and the Java interfaces and things like that, how they will map. We're going to start with one that is produce check noise. So we'll start with this one. So it is a Java supplier. It's just like a supplier that comes from your Java util function pack. So what this supplier does, essentially, it is interface that has one method. Let me do this one. If I can do, this lambda thing. IntelliJ IDEA used to can this. Yep. No, I want to do this as a anonymous class. So yeah. So essentially, there is a method get that someone will invoke, someone who will use your supplier. Someone will invoke this, and this supplier will produce something. So in this case, this interface will fit perfectly into concept of Kafka. So who will call this? In this case, we're going to be using this thing called Spring Cloud Streams, and Spring Cloud Stream has a binder for Kafka. So for now, I didn't specify anything, and it won't work until I will specify something. And one of the things that I need to specify is, usually I don't do this with YAML, but today is the day where I have to. So I'm renaming this to YAML, and we're going to be doing because it's tons of YAML. So in this case, it is one thing that we need to tell Spring Cloud Stream that we're going to be using Kafka as our binder, and it will figure out how to start producer, how to connect to the Kafka topic, and after that, how to invoke this little fella, this guy, this producer. So my computer usually not super good on running highly available and highly scalable distributed system without Kafka. So that's why I'm running this stuff somewhere on the cloud. So in this case, I will be using the Confluent Cloud, even though this thing is actually worked on any computer. So this should be fine. So I will create a quickly cluster, and I will show you how I can connect to this cluster. Go next. And my password is here. And this is how we end up in Confluent. So there is a start my own cluster, going with some basic stuff because I don't need to do anything exciting. You know, when in Rome, when in Poland, we need to run the cluster closer to Poland. And there is a GCP, GCP Central 2 has a data centers in Warsaw. So I think that will suffice for our use case. So it will not go and do a round trip around the world. So let's call it something like Devoxx Spring Kafka, and I do a launch cluster. So if you using this stuff and you want to connect your application, there's a very nice hint here. So you can go ahead and grab the configuration for Spring Boot. It has a configuration for Kotlin and has configuration. Any Scala developers here? Okay, so for Scala developers, for two Scala developers, we have configuration there. But there's a Kotlin one, and there's a Ktor one, which is also Kotlin framework. So you can also find it. This is my keys that I will be using. Bring Devoxx from stage. I'll do this one. And essentially, I need to do a couple things from here because I already have this template in my here. So I'm not gonna using local host in this case. I will go ahead and uncomment those things. We can talk about this, what they do. But essentially, this is a Bootstrap server. This is where we connect our application. Sometimes I'm struggling to read some of the like Polish signs because there's a lot of like a Z and some extra letters that create some interesting emphasis. And I think this thing is like very Polish. There's W, Z, stuff like that. I don't know if it was offensive or not, but yeah. So and the username, we go in here, and there's the password. So that's pretty much it, what I need to do. And the only reason why I want to use this cloud because it has nice UI and it comes, with the thing. And I don't want to, bring up another UI thing. So That's it. So when the application will start, like my teachers say, show, not tell. So when application will be starting, Spring Cloud Streams, Spring Cloud Streams will find the beans that will be required. So it will read this configuration. It will instantiate the binder that will connect to Kafka. And after that, it will use this bean to start producing the message. It will create a Kafka producer. How I know it's actually worked? Well, like I said, this thing has a very nice UI, and we will better use it. We do have a fact. And oh, here we go. Here we go. We do have some information about Chuck Norris. Chuck Norris can use Goto as much as he wants. We have a very senior developers who remember what the Goto was and how we were programmed this all the time with this stuff. You know, I love this stuff. I don't know why they deprecate this, not allow us to do this. So Chuck Norris can compile syntax errors, probably because he writes Groovy. Because Groovy is a dynamic language, right? So we do have it. Exciting. I think in a few seconds we have a piece of configuration that we can copy from somewhere else. We have this supplier that does the thing for us. In this case, it uses some of the pieces that comes over Spring Cloud Streams, and it has a message builder that is abstracted from the Kafka. And the interesting thing with this Spring Cloud Streams, you can use different binder that will work different systems. So same application that I showed you, Java code, will be working with other messaging system like a Rabbit, but you need to supply different configurations for Rabbit binder. But the Java code will stay the same. Now, next thing is that supplier is for producing data. Now we need to have a consumer. So in this case, I will do consume. And in this case, let me fix my static. Okay. So consumer, it's another functional interface that has one method that not returning anything, but the value will be injected here. Who will be injecting value here? Framework. So Spring Cloud Streams will create a consumer underneath and will be injecting here message of type string. Don't worry about these guys because I like to have my terminal fancy, and this is like a terminal code would just make this text italic. So, and how we can configure this one? Let me show you. In Spring Cloud Streams, like I said, we're programming against this functional interface, and we're defining function that will define our logic. So in this case, the way how the Spring Cloud Stream will find our function among other beans that are available in Spring Context, we need to put this here in definition. So this is how it finds the producer. So if you go here, the name of this bean and name here will be exactly the same. So let me copy these properties. I'll just do consume. Okay. So for consumer, what we need to do? What I need to do, and you will watch for. Okay. So it's the YAML. Errors might happen. Ooh, broke them. Do this one. And we'll do this one. We'll do YAML. So we remove app properties. Okay, I just bring this thing because it was not templated out in my case. So I can use multiple things in my application. So I just need to kind of like chain those things together. So in this particular case, my consume Chuck Norris, this consumer, this name, will available here. Some of the things are related to Kafka. Kafka doesn't care what kind of stuff you put in it. Some people putting messages, as I mentioned this morning, like messages. Some people putting images in Kafka. Also, probably, I don't know. Depends on what you want. Kafka doesn't care. The way your application does care. So your application care, and the way how you can tell application what kind of data you have in Kafka, or you sending to Kafka, or reading from Kafka. It is why specifying the consumer properties, the stuff that you're reading, and your producer property, the stuff that you're writing. So for my producer, I use string serializer that takes Java stream and turn it into stream of bytes that will be platform independent. And the same thing with the consumer. I need to specify how I need to deserialize. Another thing, for my consumer, I also need to specify where I'm getting this data. So my producer was producing this to destination full fact, and my consumer also needs to get this from destination full fact. Also, I'm specifying my consumer group. Let's make it something interesting, like Devoxx colon. So in this case, we will see this consumer group on UI, and we will know that our application is working. All right, so I will refresh it, and if it will not work, probably I will have some of the problems with my YAML, even though, 3, 2, 1, and as I promised, give me a second, my console output has italic. If you did learn something today, this is maybe one of the important things that you might learn today, that you can actually make your console output look nice. Now, let's see the topic. We see this fact that coming to this topic, and we will see exactly the same facts that coming to our application. They're exactly the same. The way how it works in the world of Kafka, different applications will be joining a different consumer group. So the consumer group that runs somewhere inside the Confluent Cloud, it will use one consumer group. But our consumer group will be Devoxx colon correct. So we're going into clients, and in consumer section, we see a couple things. There's a consumer 103. This is consumer that the cloud uses to read data from my Kafka topic. But this is our guide. This is our application that reads this data. And we also can see like how many topics this consumer can consume and like how fast this data is consumed. There should be something like consumer lag information that shows how fast this consumer is reading data. If your application not fast enough, you will see this consumer lag will be growing. So again, two functions now. We have one function that that generates our data. This producer writing data. We have one consumer that reads this data and writes it on console. Now it's time to do some processing with this data, right? So one of the things that you can easily do with no frameworks is do filtering. It's also processing, you know? You can check the message. If message will contain something that you will be interested in, you will do something with this message. If it doesn't, you will skip it. Filtering. Filtering is what we called stateless stream processing operation, meaning that in order to calculate the current step of this, stream processing thing, you don't need to know the previous result. So it's always some function, usually no side effect. Here's for Go developers here, or maybe Haskell developers, like they like no side effect, right? However, there are some cases where we need to do stream processing with state. Aggregation, summing, all sorts of the, you do Ryan average. You need to have a sum. You need to have the average calculation somehow. In order to calculate current step based on the data, you need to store intermediate data somewhere. And in this case, it's a stateful stream processing. When you evaluate in stream processing framework to dealing with your data, you need to understand like if it supports both. These days, we not live in caves, and it's not the stone age of data processing. So majority of the frameworks that exist today, they support stateless and stateful operation. So I want to show some of the Kafka Stream stuff. Kafka Streams is a library. It means that it doesn't require cluster to run. It doesn't require you to have, I don't know, like the one application will submit jobs, and there would be a cluster somewhere that will be running this, and there would be third cluster that will run your story. So Kafka Streams, it is a framework that use Kafka as a source, use Kafka as a sink. Essentially, it reads data from Kafka and writes it to Kafka. But also, it uses Kafka as a storage. All these intermediate operations for, like, if I need to store some intermediate sum somewhere or intermediate average somewhere, I store it in Kafka. I store it in local storage, and this local storage will be automatically replicated through Kafka. So let's bring some of the stream processing using Kafka Stream. And with my previous slide, when I showed third type of function. I need to use Java util function in the interface in order to create this type of pipeline inside my application. So I'll do process word, and let me do this. Okay. So let me walk you through this code before we jump right in. So my function. Can I do this one? Let me. Yep, anonymous class. So you gotta love Java, right? With all this kind of nonsense that we have here, like the generics and things like that. So, so that's why we do have now the more concise syntax. But essentially, what it does, this method apply, it has input and has output. So the way how this stream, cloud streams will map it into Kafka stream function, it will use one of the topics as an input, another topic as an output, and it will turn it into something that we call K-stream or K-table, but like in this particular case, it's K-stream. It is abstraction on top of Kafka topic. This abstraction allows you to program against this, this framework the way how you would program with Java util functions. API is very highly inspired by Java util functions, and there are some of the methods that you'll probably seen here. Now, this abstraction allows you to deal with messages, and messages will have a type. So we're dealing with not the bytes that come in from the topics, but the framework already handled thing that will be required to turn these bytes into your object. It's called surday. Surday is a combination or like a pair of serializer, deserializer for a particular type. So that's why when I specify this K stream as an input, it means that my key will have a string and my value will have a string. And as output, I want to have a string as a key and long as a value. Why is that? Because we want to have a count per word. You know, it's a hello world of the data processing. You know, when you're processing, if you're inventing a new stream processing framework, you have to write the hello world, which is word count essentially. And because it's kind of like people understand like what it's supposed to be. You have a stream of text. So what first you need to do, because we want to count words, we want to tokenize it or like separate each individual word. And after that, we're producing stream of word. Next, we need to capture how many times particular word will happen. So for each word, we will tick or like I said, Chuck 1, Norris 1, Chuck 1, Norris 1. So in this case, we will have this stream, like weird stream that will contain key and value. And the last and the final step, you need to kind of like reduce this. So for particular key, we'll have a group stream. And for particular key, we need to apply this kind of like a reduce operation that will take all of the values in the stream of Chuck 1, Chuck 1, Chuck 1. We need to turn it into Chuck 3, right? Does make sense? Who didn't write a word count using Java util stream? I assume everyone knows this, so that's why am I bothering explain, right? No? Okay. So what is happening here? So first of all, I'm using I'm splitting my stream of fact. So as an input here, I received sentences. Here, as a result, I will have a stream of word. The next thing is that I need to choose the key. So in this case, I'm using this as a key. And after that, I have a so-called group stream. And this stream will be grouped by word as a key. And after that, I apply essentially the count function. And the count function is a built-in function that allows you to do this. But you can have the method like reduce that you can provide your own function if you're doing, for example, running average or you're doing something else. So in this case, it will take me count. And when I was talking about the state, I also, my application, we will talk about this in a second. My application also needs to have this result stored somewhere. And I'm not interested in intermediate result. I'm interested in latest and greatest result because I want to my application, my microservice, because Kafka Streams is a library. So I can use this in any framework. I don't need to worry about the cluster. My application will be my cluster. I can run multiple instances in order to scale my performance, my processing capabilities of this one. So this, remember about this word count state store. We're going to talk about this on the next step. And after that, once I process this result, I want to write this somewhere. In this particular case, I'm writing this back to topic called count. All right, so go this one. And for this, I'll just do process YAML, replacing the properties with correct one. All right, and let's take a look what we have now. So we have a produce. We're writing data in Kafka topic. Consume, just for sake of displaying this information on your screen. It's nothing more. We don't do any processing here. And actual processing happens in this process word. This is how our bin, we call here process word. Now, in configurations, now we also have another binder. We have a Kafka binder and we have a Kafka Streams binder. So in order to framework Spring Cloud Streams know how to turn these two topics to the function and like put the input topic as my input parameter for my apply function and get the result and send this to Kafka. So we need to have a Kafka Streams binder for Spring Cloud Stream. And this is two guys that I was talking about, the pair, like two brothers or two sisters or like two siblings. Surday. So Surday will include information about how to serialize and deserialize string. So essentially, if I will go here and do string Surday, so the way how it looks like, it's just a wrapper that this API uses, but essentially it's just a wrapper that provides string serializer and string deserializer. Now, this is the configuration that we need to provide. Where is it? Consumer. Where's the streams? So, in terms of telling the framework where I need to get my input and where I need to get my stuff, I get it from topic fact. All my facts that my producer will generate will go to this fella, and after that we get the count. So application still working. I just stop and rerun. And we still see a bunch of stuff on the console, but more importantly, what we want to see is that topic count that we get some results. And we get some results. Why they look so crappy? This is because we using Java framework to write data into Kafka, and we're using JavaScript to display it. Remember, we use key as a Java string and the long as Java long as our value. So that's why we see nonsense on the screen right now, right? Which is fine, because some of the people or some of the systems, more importantly, who will be consuming this data, they might know what they're doing. If it's Java, they know how to read this data. So you're writing Java consumer, you already know how to write this consumer. You write the consumer, you're defining your bindings, and after that, you will start reading this data, all right? Cool, but not super cool. Sometimes you're writing applications that not for the system. You're writing applications for your users. You want to expose this information about count somehow. You want to show this on the dashboard. You want to show it, I don't know, like some JavaScript will do some fidgeting. This is not right. This is not a good thing to kind of to tell other people, go and read this data from Kafka. You have users here. Can I see the data? Yeah, read this from Kafka. Sometimes it's okay, but I'll tell you how you can fix that in order to be, good citizen in this world. Now, where's my code? Yeah. So we created this state store. So what is a state store? In inside the instance of my application, these Kafka streams can maintain like small database. It's a small key value pair. And this small database that's available through like key value, it actually can be accessed from your application. And also, it is used like RocksDB. It's embedded. It's running like a little bit outside of the process, so it will not affect your Java heap thing and stuff like that. And the Kafka Streams does a good job on configuring this, so that's why you don't know about existing of this thing. However, there's an API that allows you to also pick inside. Sometimes you don't care about these like results that come into Kafka in real time. You just want to see like what is latest and great. So that's why we will do the next thing. So the next thing is that let me do this. Where is it? Why can I do this? Anyway, so I'll just do. I'll create a REST controller. So that's why I added my the reactive thingy into as a dependency. So this controller, it would be a REST controller. We're gonna use some API tool to get this data from it. And Spring Cloud Streams provide a wrapper around this the state store thing. They call it interactive query service. Interactive query service is a part of Kafka Streams application, and this service allows you to look inside some of the state stores available. So this, in this case, like this interactive query service allows me to extract this word count state store that includes all of the information that I need. And after that, because it's a store and has a key value pattern for accessing this data, I will be simply, getting the result for a particular key. So in this case, Spring Magic will do the thing for me. I'm exposing this result as a long, and after that, my Spring will turn it into JSON or some of the text value that will be applicable to read. So, so let me quickly restart this. Restart application because I added this controller. And so what I can do here, let me do, yes, something like this will suffice for you, so you'll see. So I can do localhost 8080/IQ/word /count, and let's do chuck, right? Oh, not found, because count, because typo. And this is how you need to do this. This is how you display this information to your users, right? So, or for example, my favorite, round house. This like roundhouse. So 45 times this fact contains information about this roundhouse kick. Like we can do, if you don't trust me, we can do something like kick. Something closer, right? Because the roundhouse usually comes with a kick. So that's what we have here. So we do have an application that will producing data, that consuming the data, processing this data, and also ship this data to Kafka, where all the consumers can receive this result. We do have a service that can expose this to outside world. Now, I want to expose it to really to outside world because right now it runs on my machine, right? It's fun and cool, but I want you folks to also hit this endpoint and read this data. So this is where we're going into the world of Kubernetes. How many of you consider Kubernetes as your production? Like, if it's not in Kubernetes, it's not in production. One person. That's my hero. Hopefully, after this talk, there will be more of us. So a couple of things that we need to have here. So we need to have this application needs to be containerized. In order to do this, we need to have a Docker build and stuff like that. But I will show you today much better way. Next thing is that we need to have this configuration file shipped to our Kubernetes cluster in the form of secret, because it contains some of the information that is sensitive, like information about keys to connect to Kafka cluster. In order to get access to this application from outside world, I need to configure so-called ingress object. So ingress object, it's your load balancer that runs inside your Kubernetes cluster. And after that, we will be able to hit this guy from outside world. So let's build this. I'll just do Gradle. Where's my Gradle build image? And we're talking about, nope. Where's my guy? Yep, this is my guy. So, not WebUI. What? Drunk? No, not. So, Spring Boot comes with the plugin for Gradle that allows you to build your image. So you don't need to write these Docker files anymore. It uses technology called build packs. So build packs, while I'm talking, let you machines will do their work. So build packs, it's a technology that come from understanding what developers use to deploy their applications. A lot of the work that was done in cloud native build packs was influenced by the work that Heroku did many years ago. And what Heroku did, it's actually magically understand what kind of stuff you're running in your application based on some convention. So what we see right now on the screen is that this build pack understand that this is a Spring Boot application. So in this case, it will slice and place different dependencies inside Docker layers the way that when the next time you will building this image, it, for example, don't need to rebuild the layer with Docker or with Spring dependencies because you're not changing your Spring dependencies, you're changing your application code. Next thing is that it has like a very thin layer for operating system, so your image would be small. And on very top, it actually puts your code. And this stuff is already structured for you. You don't need to write the Docker. This stuff would be more efficient than any Docker file you write yourself. Because it's not only include like minimal required things, but the things that require for your application to run in the cloud. A lot of work was influenced by work that Pivotal did in Cloud Foundry, but since everyone else running their the applications with Kubernetes these days, this work was successfully implemented here. So now it was pushed to my personal account. Now let's do some Kubernetes work. And again, since we're doing some Kubernetes work, let's do this one. We're doing YAML. Sorry. Kubernetes. All right, so let's bring it back. So first thing that I mentioned here, we need to have a secret. So this secret YAML, this is object that we need to have. Let me put some of the comments because I also will putting some of the stuff here. Don't do this in production. I can do this because I'm doing this from the stage. But essentially what you can do, you create this secret and only replacing things that you will be using in production. Specifically, maybe you can use this as a template. Some stuff around keys and values. So this thing is create a secret that will include this application.yaml, and after that, I need to map this so it will be available for my application to use. All right, so let's do this one. Next thing is that no. So what is going on here? Maybe another indentation. No, because it's YAML, right? Should be. Yeah, exactly. What's happening? All right, we're good. So now I think we're good here. Now, deployment. It's just too many lines of code, so that's why I'm using some of the content. So one of the important things here, I'm using stateful set instead of deployment because I just want to have a nice looking the pod name. Because when you're using deployment, it will generate some of the like a Spring, Kafka, blah, 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 some of the random stuff. I want to have a 0 or what. Now, I will be deploying this is my application that I would just ship to my Docker registry. This is where I'm getting my application YAML. So I'm mounting this guy, and I accessing this to this direction. And after that, Spring Boot as a fantastic two-factor application implementation, supports overriding all the properties that we have defined in our application config through environment variable. So, for example, like you want to maybe some of the keys for your system where you need to connect, you can expose this as an environment variable, and after that, use the secret to override this in your template. Right. So we have this. And the service. So since it's a networking application, this application is connected, needs to be connected somewhere. So what we do here, we define a service. So it will be available inside Kubernetes cluster. And the next thing is that I need to define ingress. So ingress, it is something that allows us to connect this to external. So there's a the Kubernetes is like again, I like this metaphor because it's true. Kubernetes these days is like Java 2E application servers like back in the day, because there's a lot of hype around this, like in Java 2E back in the day. There's a lot of vendors who do their own Kubernetes implementations, and there's tons of consultants who did the Java 2E back in the day. I did. I'm proud of it. And now I'm doing consultancy around Kubernetes. Hey, that's how the full cycle works. So in the implementation of this thing that will be exposing your application to outside world is actually something that we can switch in. That's something that we can implement our own. And it also will be depending on the provider of your vendor of your Kubernetes. So in this particular case, we're going to be using Kong ingress controller to get to the point where we need to. So in this case, we need to do. I need to install it. So it will have. Where's my K9S? No, it's not here. There's a K9S. It's a tool that I like to use to introspect my Kubernetes cluster. Let's see, all namespaces. Now, it brings me a ingress controller, and this ingress controller, when it's fully started and things like that, will have external address. So this external address can be accessed by anyone else in this in this room, so you can get access to this application. So where's my here? So we're doing this. Wrong one. So namespace one, and we're talking about service called. What? So I'm getting service from namespace Quonk, and I'm interested in Quonk proc. No. Space. So this is my external address. This is where my application will be available through this. Let me see if I my dig. We will make this available through normal thing. Let's see. What's the IP address? Where is it? Work. Nope. That doesn't have address. Oh. Yep. Because I'm stupid. There's too many domains that I want, so I paid for them because they supposed to be look cool, and I kind of keep paying for them, and I'm using. Now I find how I can use this. So this external IP address will be bound to my application. So when I hit this, do it p and do Quonk dev. Oops. There's nothing there, but it's 404, and this 404 comes from this ingress controller. Because I didn't apply this, I didn't deploy my application, I just configured this, so now this is ready. And the way how Kubernetes allows to put different implementation, there's plenty of different implementations. There's an Nginx ingress controller. There's a like the ECO, which is like a service mesh, has its own ingress controller. There's a bunch of different, like the plenty of those. So I need to do this wrap up a little quick. So let's do this one. I'll just do apply. So what it will do in this case, it will take my image that deployed in the Docker registry. It will deploy this image into my Kubernetes cluster. It will So if we go here, let's see if application is up and running. Another cool thing that we want to see here in my application, in my deployment, is health check. So Spring Boot comes with the predefined health check. Probably I didn't put this. I didn't put this dependency. I forgot about this dependency. Probably I need to remove this, otherwise this deployment will not work. Let's do this one more time. All right, so let's do apply. But the health checks are working, so I just need to put the actuator deployment thingy there. And now, so application started, restarting, so it is firing it up. The moment of truth, right? So why we are here, TP, I'm doing this dev /IQ /count /round out. And let's see if it's actually hitting whatever I want. So it's there. IQ. Maybe I just round. Let's do Chuck. Chuck work. Chuck work. So a round of applause for me. So again, application. So you can even go and try to do it yourself right now. So you can go and hit this URL. Try to use either curl or HTTP, because if you will be using this with the browser, usually modern browsers will try to redirect you to HTTPS, and I didn't configure HTTPS here. So one last thing. If you have not enough Kubernetes, I will be talking about more Kubernetes and more applications and my this ingress controller, the best of the world. I will be talking this in an hour or so in room 4. We're going to be doing first our Kong meetup here in Krakow. I'm super excited to start this community. And with this, my name is Viktor Gamov, and as always, have a nice day.